Today we're talking about plotting ratios from a table. A ratio table is a table of equivalent ratios. So these equivalent ratios can be made by multiplying or repeated addition. So if I start with 2 to 3 as my ratio, and ice cream, the ratio of sugar to cream is 2 to 3. So this 2 to 3 ratio gets put in a table. We put the sugar on top, the cream on the bottom, and since sugar is 2, we place that in the first box, and since cream is 3, we place that in the second box. So every time is increasing by 2, repeated addition, right? Every time down here, it's increasing by 3, or again, repeated addition. So this is like taking this 2/3 and multiplying both of them by 1 and getting 2/3, multiplying both of them by 2 and getting 4/6, multiplying both of them by 3 and then by 4, and if you wanted to continue it on and so forth. So let's look at another example. In this situation, we have somebody who's riding a bike. The ratio of hours to kilometers is 1 to 8. So for every 1 hour, 8 kilometers is being traveled. So we put hours on top and kilometers on the bottom. The reason for this is because we first have to know the number of hours in order to determine how many kilometers he's traveled. So we can look at this as 1 times 1, 1 times 2, 1 times 3, and 1 times 4. Or if you were repeated addition, it would be adding 1 to each box. Down here, after 1 hour, he goes 8 miles. So 8 times 2 would be 16. 8 times 3 would be 24. 8 times 4 would be 32. Okay, here's my work for that. Again, you're multiplying the 1/8 times 2 over 2 to get this equivalent fraction, times 3 over 3 to get this equivalent fraction, and then each one of them gets put in the box. If you did repeated addition, you would see that this is increasing by 8 every time, and this is increasing by 1 every time. Okay, use the information in the table to find the number of bowls needed to hold the candy. Here we have 60, and it's increasing every time. Here we have 2, and it's increasing every time. So our ratio is 60 to 2. If we simplified that, it would be 30 to 1. Okay, so we are increasing by 60 here, so we increased by 2 here. Or if you thought about it as 60 over 2, you multiply both of these by 2, and you get 120 over 4. As you can see, that's what we got here. So the repeated addition is happening the same on the top every single time, plus 60, and then at the bottom, it's the same every time, plus 2. So this would be 8, and this would be 10. Can we check our work by multiplying? Yes, we can. 60 over 2 equals 240 over some unknown. This is our question mark right here. So 60 times 4 gives us 24, or gives us 240. So 2 times 4 gives us 8. And we could do the same thing with the 300 there. Okay, so what does that look like on the coordinate plane? Well, we have different coordinates. The bottom line is called the x-axis. This line right here, this vertical line, this one's horizontal, this vertical line is called the y-axis. I want you to take a second, pause the video, and draw this for me real quick. In just a second, I'm going to explain it a little bit more. Okay, so in this particular situation, on a cat, the ratio of eyes to noses is 2 to 1. So if I have one cat, it's 2 to 1. And that would be plotted here. 2 eyes to every 1 nose. So 2 and 1. If I have 4 eyes, how many noses would there be? Well, this is increasing by 2 every time. This is increasing by 1 every time. So this number would be 2. If you have 4 eyes, you have 2 noses. Okay, so when we have a table of numbers here, we can graph them and it will go up at the same rate. It's called a constant rate. Now we need to make sure that we label this. So at the bottom here we would label eyes. Oops, my S got away from me. And over here we would label the y-axis noses, and this would be cats. Okay, as our title. Let's look at this one. Pens versus packages. Okay, so this one is my X and this one is my Y. So I'm going to put pens down here and I'm going to label this one X. I'm going to label this one Y and I'm going to write packages here. You're going to need graph paper. We're only working in quadrant 1. This is the positive quadrant. So we're going to label this 0 and then begin labeling our x-axis with 1s. Since I'm working with 2 smaller numbers, I'm going to also label this side with going up by 1. Okay, so you should pause the video and make sure you have your labels here. And then now I'm going to start plotting these. My title is going to be Total Pens, because I'm not sure, they didn't give me a title, so I'm going to write my own here. So now let's plot this one. If I have 2 pens, I have 1 package. If I have 4 pens, I have 2 packages. If I have 6 pens, I have 3 packages. 8 pens, 4 packages, and 10 pens, 5 packages. So this is traveling up at a constant rate. So I'm going to use a ruler and I'm going to make a perfectly straight line. Now, where did this all start? At 0, 0. So let's make sure that we mark this. This coordinate is 0, 0. If we had no pens, we would have no packages. Will you go ahead and write that down for me? Make sure that you say that this is called the origin. I want you to know that this is starting at the origin. 0, 0. Starts at the very beginning. And then this travels up at this constant rate. Would it even travel off the graph if we could? Yes. We could go all the way to 11 and 12 and so on and so forth. So we're going to put an arrow here so that way people know that this isn't an end. It goes on forever. Okay? I want you to try this one on your own. It's going to be part of your do now tomorrow. We're going to talk about it. So go ahead and make sure that you label the coordinate plane and that you plot all these points. We're going to be looking for this so we can start our discussion tomorrow. And that's all I have for you today. I will see you next time.